In this lesson, you will learn how to find the determinant of a 2 by 2 or a 3 by 3 matrix. Now the question is, what is a determinant? Well, a determinant is just a number that we can find that relates to a matrix. And a determinant can only be found with square matrices. So then the question is, well, how do you use determinants? Why do we need to find this value? Well, they can be used to find the inverse matrix, which we'll discuss later. And the inverse matrix can then be used to solve systems of equations. So the determinant is crucial for each of these reasons. So the question now is, how do you find the determinant? Well, let's let A equal this matrix, A, B, C, and D. Then the determinant of the matrix A would be found by multiplying A times D and then subtracting that by B times C. And the notation that we use to signify that we are finding the determinant of a matrix is by using these vertical lines around the matrix. So notice it's different than a bracket or a brace around this other matrix. In this case, it is just a straight line, which looks kind of like the absolute value sign. So for example, if you had real numbers, 3, 2, -1, 5, to find the determinant of this matrix, I take 3 times 5 and then subtract that by -1 times 2, which gives me 15 minus a -2, which would equal a positive 17. And that's all there is to it. You just multiply and then subtract. Here's another example where we have matrix B equals 0, 4, -5, and 2. And to find the determinant of this matrix, I take 0 times 2, multiply it by 4 times -5. And then I subtract those two numbers. So what I have is 0 minus a -20, which would give me a positive 20. So the determinant of matrix B would be 20. Now for a 3 by 3 matrix, this one is a little more complicated. Well, let's say this is your matrix, and you're trying to find the determinant of this matrix. What I do is I begin by rewriting these first two columns right here and this column right here. And I'm going to write it over on the right-hand side. And then what I do is kind of like what I did with the 2 by 2 matrix, where I'm going to multiply across with these numbers, so -5 times 8 times 3, and that's going to give me -120. And then I go to the next number, the 4, multiply across this way to get 4 times 2 times 1, which gives me 8. Multiply one more time with the 0 times -6 to get 0. And then just like with a 2 by 2 matrix, I'm now going to multiply down the other way. So starting here at the 1, I'm going to go across to get 1 times 8 times 0, which would give me 0. And then do the same thing again across this way, -6 times 2 times -5, I get 60. Then multiply the 3 times 0 times 4 to get 0. So now, just like with determinants of a 2 by 2 matrix, I then am going to subtract these numbers. So I'm going to subtract all of this bottom, 0 plus 60 plus 0, minus all of these numbers up here. So when I do that, I have 60 minus the -120 plus 8 would give you -112. So minus -112 would give you a plus 112, which would equal 172. So the determinant of this matrix would equal 172. Here's one more example with a 3 by 3 matrix. Here's your matrix, and you're trying to find the determinant of this matrix. So I begin by rewriting these first two columns, 2, 3, 5, 0, 1, -4. And then I multiply across 5 times 1 times 1, which gives me 5. And then -4 times -2 times 2 to get a positive 16. And then I take -1 times 3 times 0 to get 0. And then I multiply down across the other way. So I have 2 times 1 times -1, which gives me a -2. Then I multiply 0 times -2 times 5 to get -10, 0. and then 1 times 3 times negative 4 to give me negative 12. So then I take all of these numbers down here, subtract it by all of these numbers up here. So I have this, and negative 2 minus 12 would give you negative 14. 5 and the 16 would give me 21. So negative 14 minus 21 would give me a determinant of negative 35. So that is how you find the determinants of a 2x2 and a 3x3 matrix. And that concludes our lesson for today. We will see you next time.